Welcome to this presentation on string matching in an array problem. In this video, I will guide you through the problem, approach, code, and analysis. The task is to identify all strings in an array that are substrings of another string within the same array. For instance, given an input array of strings, we aim to extract those strings that appear as part of any other string in the list. Our goal is to return a list of such substrings. Consider this example. Given the input array words which has the elements mass as hero superhero. The output is as superhero. Here's why. The string S is a substring of the word mass and hero is a substring of superhero. These results demonstrate the problem's requirement to find and isolate substrings effectively. Now let's dive into the approach. Begin by iterating through each string in the array using an outer loop. For each selected string, compare it with all other strings using an inner loop. Leverage the find function to determine if the current string exists as a substring in any other string. To ensure we avoid duplicates, break the inner loop as soon as a match is identified. This systematic approach guarantees accuracy and efficiency. Here's the first part of the code implementation. We include the necessary headers for vector and string operations and define the string matching function. This function iterates over the array and performs pairwise comparison between strings. If a substring is identified, it is added to the result vector and the inner loop is exited immediately to avoid redundancy. The result is then returned as the output. The second part of the code is the main function, which demonstrates the usage of the string matching function. We initialize a small input array and call the function to compute the substrings. Finally, the program prints the results, showcasing the identified substring in the console output. Let's break the code into digestible parts. The outer loop iterates through each string in the array. The inner loop compares the current string with every other string in the array. Using the find function, we check whether one string exists within another. Once a substring is identified, we break the inner loop to prevent duplicate entries in the result vector. This step-by-step breakdown ensures a clear understanding of the logic. The output of the code for the example input words having the elements mass as hero superhero is the vector containing the elements as and hero. In the console, the results are printed line by line, displaying the substrings as and hero that meet the program's criteria. Analyzing the complexity, the outer loop runs n times, iterating through each string in the array. The inner loop also runs n times, comparing the current string with all other strings. For each comparison, the find function performs substring matching, taking up to L big O of L time, where L is the average length of the string. Thus, the overall complexity is big O of n squared times L. On the space front, the result vector requires storage for up to n strings, each of length L, leading to a space complexity of big O of n times L. Here are the key takeaways. Nested loops are used to systematically compare strings. The find function is employed to check for substrings efficiently. To avoid duplicates, the inner loop is terminated upon finding a match. Finally, the result is stored in a vector and returned for further use. Thank you for your attention. This concludes the presentation. If you have any questions or need clarification, feel free to ask.